Okay, so we're talking about logarithmic functions. We have two ways you can write things. We have exponential, all right, and we have logarithmic. So if you will notice between the two, if you have an exponential, then that points that you will have a exponent, all right? If you have logarithmic, then that should give you a clue that there's going to be a log. So we're going to practice writing from exponential into logarithmic and vice versa. Okay, so the first way we're going to talk about is converting from exponential to logarithmic form. You always start with your base. So this is the base of my exponent. This would be the base of my log. Okay, so if I rewrite this, I would say log base b of a equals x. Log base b of a equals x. So if I'm going to rewrite these, I would start by putting a log down. And then I would say log base 9 of 81 equals 2. And I'm done. So you're just rewriting from exponential form to logarithmic form. All right, same thing over here. I've got log base 3 of 27 equals 3. And I have rewritten that. By the way, that is a true statement. All right, all of these make true statements. Okay, and the last two, this will be log base 3 of 81 equals x. And number 4, log base 5 of 0.04 equals -2. All right, and you're done going that direction. Okay, just rewriting. All right, next we will talk about going from logarithmic form into exponential form. Again, you always start with the base. So this would be b to the x equals a. So if I'm looking at my problems here, I start with the base. So I'd say 10 to the first power equals 10, and I am now in exponential form. All right, if you're really good at going from exponential to logarithmic, and you're not so good at going from log to exponential, you could sit here and say, okay, this would be log base 10 of 10 equals 1 to show that that's going to be the same, if you like to double check yourself. All right, by the way, 10 to the first is 10. Okay, it should make a true statement. So I'll start with my base on number 6, 12 to the second equals 144. And I'm done. All right, same thing for this one. 1/2, that's my base, to the negative third power equals 8. And number 8, 12 to the 0 power equals 1. So now you know how to convert from exponential to logarithmic and from logarithmic to exponential. All right? Not that bad at all. Okay? Now let's talk about actually finding the value of a log. If the log appears to have no base, the base is 10. So for instance, I have log 5 here. There's no base right here. If there's no base, that's a base of 10. All right? And in your calculator, all right, you have a button that's over here to the left, all right, that says log. If I press that log, notice that there's no base right here. Okay? And my very first problem is log 1000. Notice there's no base right here. So I immediately think, okay, this has a base of 10. And essentially what this is saying is, they're like, what is this equal to? Well, if you think about exponential form, this is 10 to some power equals 1,000. And if I actually just thought about that, 10 to the third would equal 1,000. So really, all you're trying to figure out is what the exponent is. So with that being said, I can still just plug that directly into my calculator. Okay? So I can say log 1,000, and that's going to tell me that it is 3, which makes sense to me because 10 to the third power is 1,000. So the answer is 3. Okay? Now, since that log button only does base of 10, if you're wanting to use it, that means that if you don't have a base of 10, you would have to change it. So this is what we call change of base. And all you do is take log of this number over here. So I would say log of 1/4. And I would divide that by log of the base. Now remember, this is asking what this is equal to. And if you actually changed it to exponential form, this would be 4 to the what power equals 1/4. Okay? Well, if you know the properties of exponents, you know that a negative power would flip this 4 over 1 to make 1/4. So since the value of the 4 is not changing, this would have to be a -1. But I could plug this directly into my calculator, just like it looks. So I would get, oops, wrong button. All right, a fraction. And I could say log of 1/4 divided by log of 4. So now that I have two bases of 10, it's going to tell me that that is -1. Okay? Your second option is you could plug it in exactly like it looks. So if you look on your calculator, the shortcut menu for window, if you go to alpha, window, option 5 down here is log base. So I'm going to choose option 5. Notice that it gives me a little box here where I can put something in. So I could put the 4 in there. And then I could go over to the other box and put in my fraction of 1/4. So exactly like my problem looked, and I get the -1. Either way, these two are the same thing. It's just this is written with base 10, and this has a base of 4. Okay? So you do need to know that those are exactly the same. All right, so I get -1. If I change this to base 10, this would be log of 0.04 divided by log of 25. Or I could plug it in exactly like this. I do want to see this, though, if you're working it out, okay, for homework. So make sure you put that in. This is also going to give me a -1. All right, so that would be like 25 to the -1 equals 0.04. And same thing on this one. If you change to a base 10, you have log 8 divided by log 2. You could also think 2 to what power equals 8, and that would be 3. I could plug it in either way into the calculator, and it's going to give me 3. All right, so that's how you find the value of a log. All right, now we're going to talk about graphing logarithmic functions. I'm actually going to skip that one and just do number 14. All right, so we have already had some practice with graphing, exponential things. So this is 5 to the x. That's exponential. And so what we're going to do is we're going to graph f of x. Then we're also going to graph its inverse and state the domain and range of both. So if you will notice, I've already given you x values that I want you to use. All right? So let's start with just our original function here. And we're going to make an xy table. And these are all the x values that I want to use. -2, -1, 0, 1, and 1.5. So in this case, you don't have to pick your own. I'm picking them for you. So an easy way for you to get the y values for this function are to go to your y equals and plug this in, and then go to the table and plug all these values in. You could manually do it and say 5 to the -2, 5 to the -1, so on and so forth. It's just a lot easier for you to go ahead and put it into your y equals. So if I put in 5 to the x, and I go to my table, then I would want to plug in -2, -1, 0, 1, and 1.5. And these are all the values that I'm going to get for the y values. So I'm going to write those down in my table. So I've got 0.04, 0.2, 1, 5, and 11.18. All right. Now I'm going to go ahead and graph those. Okay, so I'm going to draw myself a little graph here. All right, draw a graph. It's not that bad. Okay, so go ahead and number your graph. So because we're going to do the inverse of this as well, we're going to have to number a little bit farther than we normally would for just this one. So I'm going to have -2, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, because we have to go all the way up to 11.18. And for the inverse, we're also going to have to go to 12. Okay, and also down to -2. And you want to make sure you're evenly spaced. Mine is not perfect, but it will work for today. So I'll graph these points, -2, and then up 0.04, so that's not very far. And remember, these aren't going to be perfect. All right, -1, 0.2, then you've got 0, 1, 1,5, and 1.5, and then a little past 11 something. So a little past 11. And I'll do my best to make this look good, but let's face it, it's probably not going to be the best. I don't expect them to be perfect, but they should look like a graph. All right, and you can always check yourself if you graph that function, it should look like this. Okay. All right. So now let's talk about domain and range. So remember, domain and range just refer to all the x values is your domain, and all the y values is your range. So we've already talked about how this comes down and gets really close to the x-axis, but it never touches or actually reaches 0 or crosses. It just kind of flatlines. And if you look at the graph, on your calculator, you can see that it never crosses. It looks like it's touching, but it's really not. Okay. So when you talk about domain, this never stops continuing to the left. So we start at -infinity, and it never stops going up and to the right. And we're worried about it going to the right. So since I never stop going left and I never stop running right, that means I'm going to go all the way from -infinity to +infinity. And when you're talking about range, that's how low to how high. So this gets down here, but never crosses the x-axis. So actually, it starts at 0, right? And goes all the way up to positive infinity. Now, it never reaches 0, so we'll have to use a parenthesis. And it goes all the way to positive infinity. Okay? Okay. So now we're going to do the inverse. Well, if you know anything about inverses, you know that the x's and the y's are just going to flip places. So once you really have all of this, you already have your inverse. You don't have to do, much more than that. So I'm going to write another table, but instead of these being my x's, they're going to be my y's. And instead of these being my y's, they are going to be my x's. And make sure that you identify this as f inverse of x. Okay, use that inverse function notation. So now I've got my y's are -2, -1, 0, 1, and 1.5. And my x values are 0.04, 0.2, 1, 5, and 11.18. So I'm going to graph this on the same graph as up here. All right, so I have 0.04, -2. All right, then 0.2, -1, 1, 0, 5, 1, and 1.5, 11.18, comma 5. All right, and my graph is really off. All right. Again, my graph is not perfect. I should have used some graph paper, so you could do that, you cannot. So if you pay attention, remember when you're looking at a picture of a graph, oh, I know what I did wrong. Put that in the wrong spot. Comma 1.5. Oh, that's much better. There we go. All right, so if you look at this, remember I told you guys that an inverse is a mirror across the line y equals x, which is just up 1 over 1, up 1 over 1, so on and so forth. Okay, so if I were to draw that line in, you don't have to when you're doing your homework, but if I draw that line in, as you can see, this is a mirror, okay, across that line. So if I overlapped this, all right, it would touch each other, okay? And let's talk about domain and range. So if the x and y values change spots, then that means the domain and range are going to change spots. So if I talk about the domain here, it's going to be the range of what my original function was. And if I talk about the range, it's going to be what the domain was. And on these, the domain and range is going to be the same every single time. So you shouldn't get it wrong if you're constantly writing it down. Okay? And that's pretty much the gist of it. All right?